Okay, thank you for introduction. I'm Toshiyuki Hagiya from Toyota Motor Corporation in Japan. Japan is the middle of the night. I belong to Connected Advanced Development Department. I'm pleased to have the opportunity to make this presentation. Today, I'm talking about the acceptability evaluation of inter-driver interaction system via driving agent using vehicle-to-vehicle communication. My talk is divided into 5 parts. I'll start with talking about background and purpose. Traffic accidents have various causes, including a lack of attention and misunderstanding of interaction. To avoid accident, drivers use multiple modalities to interact with other vehicles, such as gesture and headlight flashing. Although such interactions sometimes lead to misunderstanding. So vehicle-to-vehicle communication is expected to be a new information exchange method. In addition, the interaction between autonomous vehicle and vehicles driven by a human is also a problem to be solved. We are thinking that one solution is to augment the driver's verbal interaction with the support via vehicle-to-vehicle communication. So in this presentation, I'll talk about it. Vehicle-to-vehicle communication is a technology to talk with nearby vehicle, and many researchers have proposed some concept to alert drivers of potential hazard. For example, a researcher present the concept of providing visual and audio warning by exchange the position and speed. However, cooperation with other vehicle is required in the actual environment. So exchanging only sensor data has a limitation for interaction. Therefore, in addition to the sensor data, the transmission of social message have been studied recently. One present the concept of showing driving status to others to reduce misunderstanding like the right figure. They also developed the concept of sending a like or dislike message detected from gestures. And a researcher conducted an interview survey on the necessary requirement for sending message and extracted 3 requirements, revealing who sent the message, interface with few distraction, and easy to send predefined message. They also mentioned that the voice interface is a good candidate. In this way, inter-vehicle interaction has been widely studied. However, to the best of our knowledge, the acceptability of inter-driver interaction has never been evaluated by experimental investigation. This study has 2 main purposes. First is to clarify the acceptability of inter-driver interaction via vehicle-to-vehicle communication. The second is to analyze the relationship between acceptability and driving style. Moving on the next part. First, I show you the concept of inter-driver interaction system. In this concept, a driving agent augments the driver's verbal interaction via vehicle-to-vehicle communication. There are 3 features. First, driving agent understands the driver's intention. Second, the agent sends a message to the other vehicle via vehicle-to-vehicle communication. Third, the agent notifies the driver of the message. I will explain more specifically. First, driver A requests by voice. Second, the agent A understands the request and sends it to vehicle B. Then, the agent B receives the message and notifies the driver B. Next, driver B receives it and responds by voice. And agent B understands the response and sends it to vehicle A. Then, the agent A receives the message and notifies to the driver A. Finally, driver A starts to act of driving and driver B gives way. Next, I'll talk about the apparatus of our experiment by using a driving simulator. This experiment is conducted by the Wizard of Oz method, that is, human operator operates the behaviors of the agent and other vehicles by key operation assigned to the keyboard. The role of the participant are to control vehicle and make a request and acceptance by voice. On the other hand, the operator controls the timing of the request and acceptance and the action of the vehicle by the key operation. After the operator showed the intention, the driving simulator played the agent voice and displayed the location information on the head-up display like this. In the study, 3 scenarios were implemented: right turn without traffic signal, lane change, overtaking, and the request was approved in all scenarios. In the right turn scenario, the drivers of vehicle A send a request to want to turn right first. Then driver B respond with approval and stop. In the lane change scenario, vehicle A and B are running parallel, and the driver of vehicle A send a request to want to change lane, and the driver B approve and accelerate. In the overtaking scenario, vehicle A send a request to want to overtake, and the driver B approve and change lane. In all scenarios, the participants play both roles of the driver of vehicle A and B. That is, the participants implemented totally 6 use cases. This is a movie of the experiment.
前方車両が追い越しさせてくれるそうです。気をつけて追い越してください。
Finally, the front vehicle changed the lane to give way. Let's move on to the evaluation experiment of acceptability of inter-driver interaction. First of all, I explain the procedure. First, participants fill out a questionnaire including their attribute and 16 items on driving style. Second, the participants practice driving a square course. Third, participants implemented a scenario twice for each, totally 12 times. The order was selected randomly. Finally, the participants filled out a 4-point scale questionnaire and joined the interview. The questionnaire involved 5 items for each scenario of each role. The items are useful, contribute to safe driving, not unpleasant, reliable, and preferred. The number of participants is 23. From here, I talk about the questionnaire result. This page shows the average of 5 items for each scenario of 2 roles. The higher the score, the more acceptable it is. And the neutral score is 2.5. The first 3 items are the score of sending the request, and the other 3 are the score of receiving request. The results show all score exceed the neutral, and lane change is the highest, and right turn is the lowest. And sending request was higher than receiving request, but there was no significant difference by the classical voice test. This page shows the score of each question. The left items show 5 questions, and the bar shows the score of each scenario. From the top, items are sending scenario of right turn, lane change, overtaking, and receiving scenario of the 3. As shown in the graph, useful was the highest in all questions, and the score is 3 or more, except for receiving a right turn scenario. And contribute, Next, the score of contribute to safe driving show around 2.7 regardless of the scenario. And the order of not unpleasant and preferred were the same as the overall average. That is, lane change is the highest and right turn is the lowest, and sending request had higher than receiving request. The reliable was the lowest among all the questions, especially the sending right turn scenario was the lowest among all the questions. And the value is less than 2.5, that is less than neutral. Next, I'll show the interview summary. Blue is positive comment and red is negative comment. Overall, most participants appreciate the benefit obtained from making aware of other drivers' intention. And another positive comment is that the system leads to escalating good behavior. On the other hand, some participants commented that they will turn it off if receiving too many requests. Next, I'll show impression of each scenario. In the right turn scenario, positive opinions were obtained from the viewpoint of leading to safe driving. However, more negative opinions were obtained. One is that the system makes feel frustrated due to the difference from traffic rules. Additionally, some participants mentioned that they felt uneasy and worried about the difference between a reply and actual action. In the lane change scenario, some participants commented that the system was useful because there is no alternative way for interaction currently. On the other hand, a participant implied the driving agent need to tell more detailed information. In overtaking scenario, a positive opinion is mentioned from the viewpoint of no other alternative way, as same as lane change scenario. The other positive opinion is about the easiness to understand to use due to existing sufficient time for interaction. On the other hand, negative opinions were acquired from the perspective of the anxiety of travel. From these results, we made four hypotheses to improve acceptability. The first is use case, no alternative way for interaction. When vehicles change lane, if 2 vehicles are running in parallel, the driver can't see the turning signal. And when overtaking, there is no way for communication in the official. From this point of view, this system could be effective in situations that don't have interaction way or unfamiliar situation. The second is use case with current traffic rule and manner. So in the turn right scenario, some participants felt comfort in terms of traffic rule. The third is sufficient interaction time. In the turn right scenario, the vehicle communicates with the oncoming vehicle, so there is no enough time. Therefore, if the driver acts differently from the replying, it leads to accident. This is one of the reasons why reliability was low in sending a right turn scenario. Based on this perspective, if the vehicle can automatically judge and control, reliability can be improved because there is no room for the driver's decision. The fourth point is the transparency of the function of the agent. As a matter of course, it's important to tell the driver what the agent can do and how to make a decision. Finally, I talk about the relationship between acceptability and driving style briefly. First, I explain the procedure of extracting significantly correlated combination of acceptability and driving style. The first step is calculating score of 8 driving styles from the result of 16 items of the driving style questionnaire. The 8 driving styles are shown below. The next step is calculating the Spearman's p-value of between driving style and each question of each scenario. The final step is extracting the significantly correlated combination. The driving style of 1 to 4 are statistically correlated with some question of the scenario. This is the scenario. This is the result. The left is the driving style, and the next two are the scenario and the question that are correlated with the driving style. Confidence in driving skill had a significant negative correlation with receiving the overtaking request. Hesitation for driving means a degree of unwillingness to drive. This item had a positive correlation with some question of overtaking and right turn. Impatience in driving had a significant negative correlation with sending a request of right turn, and methodical driving had a significant positive correlation with some question of right turn. Here is the discussion. In terms of the relationship with driving confidence, drivers with less confidence are more acceptable to receiving requests. On the other hand, there is highly acceptable use case regardless of confidence. For example, the score of lane changing was the highest among the three scenarios, and the item was not correlated with any driving style. In terms of the relationship with personality, we can say personality influenced the acceptability of some use case, because in the right-hand scenario, drivers with cautious personality had higher acceptability. On the other hand, drivers with impatience have less acceptability. So to make it popular, it is important that drivers can choose whether to use it or not in some use cases. This is summary. In this study, we evaluate the acceptability of inter-driver interaction through 3 scenarios. And we made 4 hypotheses related to the acceptability. And as shown, we found that driving confidence and personality influenced acceptability in some scenarios. Finally, I show the limitation and future works. The first is limited situation of the scenarios. Conducted scenarios were simulated only low traffic world, but we are sure that they are effective scenarios in a situation of heavy traffic. Therefore, additional experiment in various environments are needed. Second is a difference in danger awareness between a simulator and the real world. Experiments in the real world are indispensable in making a detailed subjective evaluation. Thank you. Thank you for listening.
Thank you for your presentation. It was very nice. So we do have some question in the chat. Do you have any idea to avoid troubles? It's a question asked by Sachi.
Yes, it is very difficult question. In this system, it's quite different. our study was implemented on driving simulator, so it is quite different with the real world. On real world, there is possibility to make mistake in communication with the vehicle. We think two main technology are important to realize the system on real world. One is positioning measurement system, such as high accuracy GPS and the vehicle sensor data, including camera. The other is technology to link the vehicle network ID and the actual vehicle that driver want to communicate with. To realize it, HMI to specify which vehicles to communicate with is important. And AR display is a good candidate, but I think it is difficult with the current technology yet. And we think it is important to use feature of the vehicle, such as the color and the vehicle type, maker's name, and the number plate.
Okay, thank you. We have another question about have you seen acceptance difference in function of the age of your participant and about the experience of their driving as well?
In this study, I don't consider the age, just driving style.
Okay, thank you. I do have a question about your eight driving style that you propose. Can you explain it a bit more how you came up with this driving style based on the questionnaire, if I remember correctly?
Uh, yeah, question of driving style is like this.
Oh,
Confidence in driving include I'm not good at changing lane when there's traffic, and I'm confident in my sense of vehicle. Why wheels like that.
okay, thank you. And last question I will have it's about more about the limitation of your prototype. Can you explain it a bit more because I understand you have been studying a simulator, and when making in a real world environment, it will take some effort. So, do you have any idea of how you will display it and try to test in a real environment?
I'm sorry, I can't answer currently.
Okay.
Sorry. Yeah, it is under consideration in our company.
Okay,
Sorry.
good. No, that's fine. That's fine. No worries. So, if you don't have any more question for you, I think we are going to the next presentation. Thank you again for your talk and being up at this hour for you, I think, in Japan. So, have a good night for you
Yeah.
and and see you.
Yeah, thank you.